Hello. All right, this is an instructional video on how atoms come together to make molecules and how they bond. So we're going to finish up this notebook, and you guys have a study guide that goes along with this. So a worksheet that you're going to fill in with this video. I am embedding some fun facts about Mrs. Wagner as we go through the video, so make sure you listen to those little fun facts there. All right, let's start with fun fact number one. I was born in 1971. I have an older brother and an older sister. My sister's name is Elizabeth and my brother's name is David. And probably the most interesting thing that happened when I was born was my brother, who wanted a little brother instead of a little sister, ran away. He was 7 years old, and he got on his bike when I was born. When he found out that it was going to be a girl, that he ran away, and they couldn't find him like all day. So that's the wonderful start of that relationship between my brother and I. We're actually pretty close now, but growing up, not so much. He really wanted a little brother instead. Oh well, he got me. Okay, so let's talk about yesterday's assignment. Going over this lesson from lesson 8, this slide. As you watched the video and reviewed the slides and looked at the brain pop, this is what you should have gotten for slide, I think it was 113. You were given proton that is located inside of the nucleus. The mass of that is that it's in between the smallest and largest mass of the three subatomic particles. So it's the one in between. It has a positive charge. The one above it is electron. This is on the outside of the part of the atom in the electron cloud where it circles the nucleus. All of the electrons kind of whiz around the nucleus, kind of like planets orbiting the sun. Of the three particles, this one has the smallest mass. It has a negative charge. The neutron is located inside the nucleus. Neutron sounds like neutral. Neutral means no charge, so it does not have a charge. And it's the largest mass of the three. All right. Okay, so here's lesson 9. And now that we've talked a little bit about atoms, let's talk about how they combine to make molecules. So we have a few examples of some models of molecules, and there are different colors within that molecule just to show you that they are made up of different types of atoms. So we've got one over here. We have green atoms with yellow atoms and a gray atom in the middle there. So we have two compounds, two molecules. All right, so before we get into compounds, let's talk about how some atoms can combine with each other to make elements. So the same type of atoms combine with each other. They group together to make elements. So an example of this would be lead. A lead atom will combine with another lead atom to make lead. Gold will combine with gold to make gold. And then this is oxygen gas. This is gas that you breathe in. It's made up of two oxygen atoms. And that is a molecule. It's an element because it's made up of the same kind of atom. But because we have two joined, it is considered a molecule. All right, but many things on Earth and most of Earth's matter is made up of a combination of different atoms to make compounds. So when these atoms combine, they're going to create a new substance with new chemical and new physical properties. Water is an example of this. Water, for instance, is made up of hydrogen and oxygen atoms. We know it's H2O. Both of those, hydrogen and also oxygen, are gases at room temperature. So room temperature, 21 to 23 degrees Celsius, which is about 72 degrees Fahrenheit. Pretty comfortable room. And all around you, you have oxygen atoms that you breathe in. Okay, hydrogen atoms are a gas as well, and they are at room temperature, both gases. So take a look at these physical properties of hydrogen and oxygen, their freezing point. The freezing point of oxygen is 218.79 degrees Celsius, the one above it. Freezing point of hydrogen is negative 259.14 degrees Celsius. So in order for them to become a solid, we've got to dip way below 0 degrees Celsius. However, when we combine them chemically and we make water, freezing point of hydrogen and oxygen as water is only 0 degrees Celsius. So we can turn water into ice by putting it into just like a normal freezer and bringing it down to 0 degrees Celsius, and there you have ice. So when the two gases are combined to make H2O, water, we have a completely new physical property, a new freezing point, just by combining them. All right, another fun fact about Mrs. Wagner is growing up, her very best childhood friend was named Andrea, and we are still best friends to this day. I see Andrea a few times a year. She lives over on the other side of the state, and we probably text almost every day, so we're still very good friends. A couple things about Andrea. Andrea is responsible for the dimple you see on Mrs. Wagner's right cheek here. I was not born with that dimple. Andrea pushed me in a sled we were sledding. Well, interestingly enough, we were sledding on somebody's roof. So this person in our neighborhood had one of these, like what they considered kind of an underground house. And the top of the house was the roof, obviously, but it connected to a hill and the back of it. So neighborhood kids, whether they were invited or not, would come to this house and sled off this family's roof. And in the back were woods, so there were all kinds of trees. And Andrea pushed me in the sled. Not that it was her fault, but I do blame her. And I hit a tree that had a whole bunch of limbs sticking out, and one of them got me right here, formed a blood clot, and the blood clot turned into this dimple as it healed. So, that's my little Andrea, always remembering Andrea with my dimple. Okay, moving on. Bonding of atoms to make molecules. So atoms do bond with other atoms to make molecules. So here's our hydrogen gas, H2. Here's our oxygen gas, O2. Remember their freezing points were negative 200 and something degrees Celsius. It's going to require 4 hydrogen atoms and 2 oxygen atoms to make 2 complete molecules of water. Okay, so how do they bond? How do they go about, we know in a chemical reaction that the bonds break apart and then they recombine and form new molecules, such as our water molecule here. But how do they actually come together? Let's take a look at this. So bonding of hydrogen atoms, when 2 hydrogen atoms get close enough, so this would be your hydrogen gas, the electron, so remember that as a negative charge, from each atom feels an attraction, quite like a magnet, from the proton. Remember, protons have positive charges in the other atom's nucleus. So you've got a negative charge of one atom coming close to a positive charge of an electron of another atom. And when they get close enough, it's like 2 magnets coming together. They stick and they bond. This attraction pulls atoms together like magnets. The electrons end up being shared by the atoms in a region around the nucleus, the electron cloud, of both atoms. Let's take a look at the animation. So we have our hydrogen, which is a positive of one atom. This is the proton. And we have the negative electron of this hydrogen atom. So that's one hydrogen atom. And we have another hydrogen atom. There's its positive proton in the nucleus and the negative electron. And we're going to see how they bond to make hydrogen gas. So pretty simple, just like magnets, they just boop, attract to each other and they come together and form now H2, which is our hydrogen gas. Okay, so the hydrogen atoms are close together. The electron from each atom feels the attraction from the proton in the nucleus of the other atom. They pull together. The atoms bond because there's a strong enough attraction in both directions and room for the electrons in the outer energy level, that electron shell of each atom. Okay, so this is just a little model of that. We've got the positive connecting to the negative. We have the negative connecting to that positive. They share their bonds. They share their electron bonds. And here we have our hydrogen gas. All right, so let's take a look at how this happens with water. So now we have our 2 hydrogen atoms and our 1 oxygen atoms, and they're bonding to become water. Hydrogen atoms and oxygen atoms are close together. The electrons from each atom feel the attraction from the protons in the nucleus of the other atom. This attraction pulls the atoms together. The electrons are shared by both atoms. The atoms' bonds are because there is a strong enough attraction in both directions and room for the electrons in the outer energy of the level of the atoms. So we'll take a look at the animation. All right, covalent bond in water. There's our hydrogen atom. There's our hydrogen atom. At one point, these 2 atoms were bonded to make hydrogen gas, but a chemical reaction occurred, and now they're bonding with this oxygen atom. This oxygen atom has 8 electrons. So let's see how they connect. And connect. All right, so now we have H2O. We do have some free flowing electrons here, but our hydrogen do not have any other free flowing electrons. So this water molecule will not bond with any other element. So we're not going to get another oxygen atom to connect with this molecule. It is complete. H2O. All right, so here is just sort of a picture of that. Our 2 hydrogen atoms, our oxygen atom pulling together, attracting protons, attracting with electrons, electrons attracting with protons. Their bond is strong, so they become a molecule, and it will take a chemical reaction for it to break apart. Okay, so another fun fact about Mrs. Wagner and her friend Andrea. So when we were kids, we found ourselves in all kinds of little shenanigans. In my day, being a kid, and I kind of hope it's like this with you guys too, we were allowed to just kind of run around the neighborhood, and we would just tell our parents, we're going outside, we're going to be outside, and we were gone all day. Our parents didn't really know where we were most of the time. We just stayed in the neighborhood and played with neighborhood kids. So we would put together fun little shows like carnivals and haunted houses. We would build these carnivals and these haunted houses. I wouldn't say they were the safest thing ever, but we had a lot of fun, and we would charge neighborhood kids to attend our carnivals and our haunted houses. So we were kind of little entrepreneurs growing up, and all the neighborhood kids would come and pay us to go through our haunted house or be part of our carnival. I think we charged like a nickel or a dime or something like that. It was a lot of fun. Okay, so let's talk about changing just one atom changes everything. So we know that atoms make up molecules, and there are all kinds of different molecules that make up matter. So when different atoms combine to form molecules, they do so in specific ways. Adding or taking away an atom can result in a completely different material, a drastic change to the matter by just taking away or adding one tiny little atom. So for instance, the formula for glucose, which is a sugar, just regular sugar that all life depends on. Here's the formula, C6H12O6. This is the sugar that plants make in photosynthesis. If we take away one H and we make it H11, so we have C6H11O6. It's L-ramonate, which is a completely different molecule. This molecule instead, so it's not sugar anymore, it is now a molecule that treats bacterial infections in humans. A totally different substance with different physical and different chemical properties. You aren't going to use sugar to treat bacterial infections, but we take away one hydrogen atom, and now we have this medication that treats infections in humans. So the small numbers, we talked about this before, let us know how many of each type of atom there is in the formula or the recipe. So here's what that kind of looks like when they bond. All right, this is another example of different molecules. Some molecules, they can have the exact same number of different types of atoms. So we talked in the last slide about just removing an atom and making a completely different substance, but their arrangement matters as well. So how they are arranged in the molecule can make it a completely different substance. So for example, we can use the same group of Legos to make many different items, right? You could have 25 different kinds of Legos. You can make one thing with those 25 Legos, but if you take them apart, rearrange them into a different formation, then you might have a completely different looking structure. And that's exactly what happens with molecules, okay? We can have the same number, and if they're arranged in a different way, they're going to be a different substance, okay? Butane and isobutane, they have the same types and add a number, amounts of atoms, as we can see in the model down there, but they are arranged differently, and that gives them different chemical and physical properties. So let's check it. Butane has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens and 4 carbons. Isobutane, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4. So the same type of atom, the same amount of atoms, but arranged differently does make them different substances. And butane's freezing point is negative 135 Celsius. Isobutane has a lower freezing point, negative 159.6 Celsius. So those are different physical properties. Okay, so that concludes those slides. And like I had mentioned, you are going to have a formative assessment, a quiz next week, okay, on lesson 8 and lesson 9, okay? All right, another fun fact about Mrs. Wagner. Let's see. Well, here's a couple of fun facts. We talked about my brother. Andrea had a brother too. His name was Doug. Doug was a few years older than us, and he was a hockey player. He was actually a really good hockey player. He played in college as well, and his dad, Andrea's dad, was a hockey player at Western Michigan University and then also coached hockey at Western. So hockey was a really big thing in their family. Andrea and I actually got into figure skating. We were figure skaters all through childhood, and we're on a precision team, which is like a skating synchronous team. And we used to do shows for Western Michigan hockey games, like in the halftime show. She was better than I was. I was an okay skater. She was a pretty good skater. But we had a lot of fun. But anyway, Andrea's brother, Doug, had to do a lot of practicing for hockey. And they had this makeshift goalie net down in the basement. And he used to have to practice like shots into the net down in the basement. He thought it would be fun to dress us up in hockey gear, pads and helmets and all the things that you would wear on your hands, like what goalies would wear, to try to block his shots. So he would literally shoot hockey pucks at us, and we would try to block his shots and help him practice. That was kind of fun. It was a little dangerous. We didn't really get hurt. We had enough padding on, but yeah, that was a fun time with Doug. All right. Let's see. Another fun fact. Things that Andrea and I liked to do. We went canoeing a lot with our dads. And they would take our brothers, David and Doug, canoeing. And Andrea and I always wanted to go canoeing. So when we were like 8 or 9, they started taking us on the canoeing trips. And that's probably a big highlight of my childhood, was going canoeing. If you've ever been to the Pine River, we would always go a lot to the Pine River and canoe and camp. I did enjoy camping as a kid. Not much of a camper now, but I did enjoy camping and canoeing as a kid. Okay, I think that's it. We're at the end. Just a little fun trip down memory lane into my childhood. Hope you enjoyed that. All right, that's it. And don't forget the study guide. If you have not been filling that out, you do need to go back and fill out the study guide. There will be some questions on there, as you can probably already see, about what you learned yesterday about the parts of the atom, and again, molecules and how they bond. All right. See ya.